In this presentation, what we're going to do is continue on with our series of revision on the differentiation. So what we're going to do is question 10 to 14. Now, most of these feature the power rule specifically. And essentially what we have here, if we have f of x equals x to the power of n, then the derivative is going to be, which we denote f dash of x or f prime of x, or essentially we have that little superscript up here. Okay. Essentially what we're going to do is we first off isolate the value for n, okay, and we pre-multiply it by our resultant value here. So we take out the n and put it down the front. X to the n minus 1. Okay. Just as a remark, the derivative of a constant is 0. So if k is some constant, the derivative is going to be the derivative of that function is going to be 0. Okay, so that's going to be important here. Okay, and also if you have multiple terms, you can sort of differentiate each and then just add up the resultant terms. So question 10 is f of x is equal to x to the 5 plus x to the 3. Okay, so what we're going to do here in both cases is like essentially identify n. In this case, n is going to be 5, and here n is going to be 3. Okay, so our derivative is essentially we can just take both parts separately. So we can take this part and then this part. Okay, and essentially what we do here is remember n, so is 5. Okay, so 5 times x to the power of n minus 1, so that's 5 minus 1, or in other words 4. Okay, plus here for the second one n is 3, so 3 times x times 3 minus 1 is 2. So that's the answer to question 10. Okay, simple as that really. The second one is very similar. Okay, sorry, the question 11 is very similar. This is the second one for this series. F of x is equal to 2x squared plus 4. Now I'm just going to sort of present the answer to this one. I'll let you just sort of see that you get this yourself. This is 4x, simple as that. Essentially we have 2x squared, 2 times 2x, the derivative of x squared is 2x, and 2 times 2x is 4, and we have a constant term there. That is to say, it's not in terms of x, it is just a constant term, so plus 0. Okay, so 4x plus 0, or in other words 4x. Okay, so what we'll do now is question 12. Okay, they're going to get a little bit harder now. Here what we're dealing with is f of x is equal to 3 times the cube root of x. Now this is a bit more complicated. What do we do here? Well, essentially the key thing here is that we can rewrite the cube root as 3 times, so this is the important bit here, x to the power of 1/3. Okay, now we're okay. Okay, so essentially what we can do here is this term here, essentially what we have to do is differentiate this bit here according to the power rule. Okay, so essentially what we have here is f dash of x is 3 times 1/3 times x, and the power is 1/3 minus 1. Okay, so I'm just doing this very slowly. So that's the derivative of this is this part here. Okay, the multiplying it by 3, we just said take that separately. So 3 times 1/3, that just cancels out. Okay, the 3 times 1/3, that just cancels out to 1. So all we are particularly interested in is this part here, which is x to the power of minus 2/3. Okay, or in other words 1 over x to the power of 2/3. You can leave it your answer like that. Actually, that would work fine. But essentially, the key thing there in this presentation is, for this particular question, is knowing to go from that the cube root of 1/3 can be expressed as that. That's the key thing for that particular question. So that was question 12, Q12. So we have 2 more in this presentation. Q13 is f of x. This is a big long one actually, but there's nothing actually particularly hard about it. 2x 5 plus 8x squared plus x minus 78. Okay, now I'll do this out a little bit again. So here n is equal to 5, n is equal to 2, here n is equal to 1, and so on. And the last case, n is just, the 78 is just a constant term. So f of x equals here 2 times 5 to x, 5 times x. 5 minus 1 will give us 4, okay? So that part there is going to be worked out to be 10x to the power of 4, okay? This next part here, we'll just say and ignore the 8 there, or just leave it out on its own. 2, bring down the n, x, 2 minus 1 is just simply 1, and x to the power of 1 can just be written as x. So what we have here is 16x. Now, plus 1, or plus x, that is, well, we can actually write that as x to the 1, so we have 1 times x to the power of 0. Okay, x to the power of 0, anything to the power of 0 is necessarily 1, so what we end up here with is simply 1. Okay, so the answer to this one is 10x to the power of 4 plus 16x plus 1. Okay, and finally one more just to finish up, question 14. This is f of x equals 7x to the 7 plus 8x to the power of 5 plus x cubed minus plus x squared minus x. Okay, actually maybe later on what I might do is in later editions I might knock out a few of these later terms. So if you're just looking at a video where these terms are gone, don't worry about it. It's just I decided later on to get rid of them. So what I'm going to do here is essentially something very similar here. We have 7 times 7 times x. 7 minus 1 is 6, so we have x to the 6. Okay, so that is 49. This is f dash here, or the derivative, f dash, just to give it a sort of nickname turn. So 8 times x to the 5, so that's 5 times x to the 4, so that is 40 x to the power of 4. The next term here is 3x squared. I'm just going to sort of give the answer to the rest of them there, plus 2x minus 1. Okay, so just bring those down. 3x squared plus 2x minus 1. They're very similar to things we've done already. So that's the derivative of that one. It's a lot of very sort of simple use of the power rule there. Okay, for derivatives. But I think you should be okay with that now. So the question 15 to question 19 is something very similar, something a bit more challenging, but that's enough for this presentation. This is question 10 to 14 for differentiation review.